Hi dear students, now we are at unit number 2, Eigen Values and Eigen Vectors, lecture number 3. So this problem I have discussed in the last lecture number 2. It is supposed to find Eigen Values and Eigen Vectors, Eigen Values and Eigen Vectors, but I found only Eigen Values in the last class. Now let us find Eigen Vectors in today's class. So till this I have done. So eigenvalues are 2, 2 and 8, 3 eigenvalues, and now we are at eigenvectors. So eigenvectors can be calculated by using this equation: a minus lambda into I into x bar is equal to 0. And case 1, first eigenvalue 2. So with respect to 2, let us find what is eigenvector. So then replace lambda is equal to 2 here in equation number 2. So a minus 2i into x bar is equal to 0. So from here I will continue. Okay. Now let us continue from here. So yeah, result a minus 2i because lambda is equal to 2 into x is equal to null matrix. So first, what is a? We have to write. Go back and look at a. 6 minus 2, 2. Okay. So 6 minus 2 and 2. Next line, minus 2, 3 minus 1. Minus 2, 3 and minus 1. And the last row is 2 minus 1, 3. 2 minus 1, 3. 2 minus 1, 3. So this is matrix A. Okay. And minus twicely identity matrix. So since here A is of order 3 by 3, therefore identity matrix of order 3 by 3 we have to take. Okay. So this is the first observation in this. For example, if the matrix A is of order 4 by 4, A is of order 4 by 4, then take identity matrix of order 4 by 4. Okay. And this one, okay. And this all these things into what? Here x bar is x1, x2, x3. Why it is x1, x2, x3? Because and this is 0, 0, 0. Why? Because look at A is of order 3 by 3, right? A is of order 3 by 3, right? And what about identity matrix? It must be 3 by 3 because A is of order 3 by 3. So identity matrix of order 3 by 3. Now 3 by 3 matrix minus 3 by 3 matrix. Again resultant 3 by 3 I will get here, right? So this is 3 by 3 matrix. Which one? This A minus 2i is of order 3 by 3. Okay. Now this entire matrix of order 3 by 3. Like look at here. Now simplify this. This matrix minus 2 into identity matrix. So subtraction of 2i from A. So now 2 into 1, 2. So what is the resultant matrix? 2, 0, 0, 0, 2, 0, 0, 0, 2. This matrix we have to subtract from this. What will we get? 6 minus 2 is 4. Okay. And minus 2, 2. Right? And here minus 2. And 3 minus 2, 1. And minus 1. Okay. And 2, minus 1. And 3 minus 2, 1. So this is the resultant matrix of A minus 2i. And what is the order of this? This order is 3 by 3. Look at this is 3 by 3. Okay. So the resultant matrix order is 3 by 3. Now look at into x is there. Into x is there here. So when the matrix multiplication is possible, so here this matrix number of columns should be equivalent to the next matrix number of rows. Okay. So here the number of rows must be 3 only. Then only matrix multiplication is possible here. That's why I am taking 3 by 1 matrix here. It is 3 by 1 matrix. That's why here I have taken x1, x2, x3. For example, if A is 4 by 4 matrix, okay, then identity matrices should be 4 by 4. So that this matrix order must be 4 by 4. This matrix order must be 4 by 4. Then here I need to take 4 by 1 matrix because it is 4 by 4, right? So now at that time x1, x2, x3, x4 I have to take since it is 4 by 4 matrix. Since it is 3 by 3, now we will take 3 by 1 matrix. And this is equals to Again, the resultant matrix, what is the order of resultant matrix? Resultant matrix order is, here you look at, number of columns of the first matrix is equal to number of rows of the second matrix. Then the resultant matrix order must be 3 by 1. That's why this is 3 by 1. Look at, this is 3 by 1. Okay, that's why here I am taking 3 by 1 matrix, here also 3 by 1 matrix. Fine. So now our goal is to find what is eigen vector, right? Eigen vector. That means I need to find what is this indirectly. Yes or no? So this vector I need to calculate indirectly. What is this? Okay, this is nothing but x bar, right? So this x bar, this is x bar. So this is nothing but x bar. So I need to find this unknown. Indirectly, see, for example, if this one some B, some matrix B, this is some x and this is some C. So indirectly this is system of linear equations only. So this is a matrix representation of system of linear equations. So indirectly we have to solve to find the vector eigenvector x1, x2, x3. We have to solve this system. Solve the system. How to solve the system? By using Gauss-Jordan elimination method. That's it. So again, old technique we have to apply. Understood? Our goal is to find x1, x2, x3. Now let us compute. Okay. So here, how to find solution to this system of linear equations by using Gauss-Jordan elimination method. For that I want augmented matrix. So what is augmented matrix in this? B, C. Adjoining of B, C. So this is augmented matrix. Now let us write 4 minus 2 and 2 minus 2, 1 minus 1 and 2 minus 1 minus 1. Okay, this is B and C column 0, 0, 0. You have to insert this column. Now this is augmented matrix, and here we need to convert this matrix into reduced echelon form. After that we have to rewrite the system of equations. Then we can find the solution to this system of equations. Finding solution to this system of equations means directly we are finding x1, x2, x3. Finding x1, x2, x3 is nothing but finding eigenvector x bar. Our goal is to find x bar only, right? That's what. Now let us proceed. So here I want to modify the first row. R1 is modifying as R1 divided by 2. Again I am not dividing with 4. Why? Because if I want to divide with 4, what happens? Here two fractions I will get. Dealing with fractions becomes somewhat difficult. That's why I am not dividing with 4. I am dividing with 2. So try to play with integers. It is very easy. Now let us divide with 2. So 2 minus 1, 1 and 0. Okay. And here minus 2, 1 minus 1 and 0. And last row 2 minus 1, 1, 0. Okay. Next one. Continue from here. Yeah, our goal is to find this one should be 1 and these two entries must be 0. So forget about making this one as 1, because if we want to make it 1 we have to divide with 2 so that these two becomes fractions. Don't concentrate on this making 1. I will do this at the end. Let us try to make these two as zeros. Now let us modify the second and third rows. Now R2 is modifying as clubbing of first row and second row so that A21 becomes 0. And similarly R3 third row and third row R3 minus R2. Shall I use R2? I should not use R2 because R2 is modifying row here. See, for example, if I use this one, look at once. Though this entry becomes 0, but I should not use this operation. Why? Because R2 is already modifying. So modifying row we should not use here. Okay. So try to change the row operation. Okay. Now, so R3 minus, okay, R3 minus R1 and 2. This is perfect. Yeah. Now let us you write R1 as it is because it is not modifying. 2 minus 1, 1, 0. And second row is modifying, clubbing of first row and second row. 0, 0, 0, 0. Wow, all are zeros. Next, R3 minus R, 0, 0, 0, 0. You get all are became 0. And next one more step, it is not required. Directly can write without confusion. avoid the confusion. So R1 is modifying now R1 by 2. Okay, and this one is now 1 minus half plus half 0 0 0 0 0 and 0 0 0 0. Okay, so here, yeah, is it reduced echelon? Check once. So first non-zero entry 1 and remaining all are zeros. So it's perfectly reduced echelon form. Then what we have to do? We have to rewrite the system of linear equations. So rewrite the system of linear equations. Let us rewrite. Then, so this first column represents x1 variable coefficient, second column for x2 variable coefficient, and third column for x3 variable coefficient. Last column is constants. Now let us write 1 into x1. Okay, 1 into x1. Next minus half into x2. Okay, next plus half into x3 is equal to 0. And only one equation is got. So this implies which is x1 minus 1 by 2 into x2 plus 1 by 2 into x3 is equal to 0. Okay. Now here let us take so two variables x2 and x3. So let x1 is equal to some k1 and so x2 is equal to some k2. So k2 belongs to real number system. So here k1 also belongs to real number system. So here k1 also belongs to real number system. So both are belongs to real number system. Okay, but not both simultaneously zeros. Why simultaneously? Simultaneously 0. Why? Because a real number system having 0. Okay, if k1 takes 0 and here also k2 takes 0, what happens? K1 k2 both become 0. That means x1 x2 both become 0. If x1 x2 both become 0, then x3 also becomes 0. Then what we are getting? x1 0, x2 0, x3 0. And directly eigenvector is null vector, but eigenvectors are non-zero vectors. If you look at the definition of eigenvector, eigenvectors are non-zero vectors. That's why we have to make it as a non-zero. That's why both k1 k2 should not be equal to 0 simultaneously. If k1 is taking 0, then k2 should not be equal to 0. So here I am taking x1 is k1 or x2 is equal to k2, or you can take like this also. You can take like this also. Here x2 and here x3 you can take. No problem. Let us take x2 is equal to k1 or x3 is equal to k1. Any two variables to take, your wish. Okay. I am taking x2 is k1 and x3 is k2. Now assume this is equation number 1. So equation number 1 implies, what happens? What will be x1 from that? X1 is equal to, what is it? Half times x1 minus half times x3. Okay. Half times x2 minus half times x3. So half times, what is x2 value? x2 is k1, right? We are assuming x2 is k1. So k1 minus half times x3 is how much? x3 is k2. So x1 value we got. Already x2, x3 we are assuming. Now finally, now the final solution is, so therefore solution is equal to, what is solution? x1, x2, x3, isn't it? So this is equals to What is that? Now what is x1? x1 is half times k1 minus half times k2. Just now we computed this. And what is x2? x2 is k1 and x3 is k2. Okay, so this is a solution. If you want to simplify more, or you can simplify like this. Take the matrix, the entries as it is, half times k1 minus half times k2 here, half times k2. But look at your second entry, k1, right? I can write this one, k1 plus 0 into k2 I can write. To simplify this, we will get k1 only, right? Similarly, second one, 0 into k1 plus k2. This is just for understanding purpose I am writing, or directly you can take common if you are understanding well. So now here what happens? Let us take k1 common. Okay, I am taking k1 common, k1 common. If you take k1 common, half, here what is k1 in second entry? 1. In third entry, the k1 entry is 0, like this. Plus, next k2 common. Take k2 common, first minus half in the first entry. Second entry k2 coefficient is 0. Third entry k2 coefficient is 1. Like this. Like this you can express your wish. Okay. Or you can stop till this, no problem. Till this you can stop, no problem. Okay. So this is about solution of the given system of linear equations. So therefore the final conclusion is, therefore eigenvector corresponding to the eigenvalue lambda 1 is equal to 2 is, what is that? X bar is equal to, x bar is nothing but eigenvector, right? Which is nothing but this one, k1 times, let me write this clearly, yeah, so k1 times half 1 0 plus k2 times minus half 0 1, like this. So this is eigenvector with respect to the eigenvalue lambda 1 is equal to 2. Okay, so this is with respect to lambda 1 is equal to 2. Clear? Similarly, for the second eigenvector, that means with respect to the eigenvalue lambda 3 is equal to 8, because two eigenvalues are same. Lambda 2 is again 2 only, so 2 is same. Again, if you compute the calculation, again same vector will get. So with respect to the eigenvalue 2, this is eigenvector. Next, the second one, case 2. Case 2. Now with respect to the eigenvalue, third eigenvalue, which is 8. With respect to this, what is eigenvector? We need to calculate this. Okay. Again same story, a minus lambda i3 I x bar equal to null vector, right? Let us replace a minus, a is of order 3 by 3, therefore lambda here 3, and therefore identity matrix of order 3 by 3 I take, because a is of order 3 by 3 into x bar equal to null matrix. Okay, so a minus, so therefore a minus lambda value is 8 and identity matrix of order 3 by 3 into x bar equal to null matrix. Okay, now let us write the A matrix. Matrix A, 6 minus 2, 6 minus 2, 2, and minus 2, 3, minus 1 is matrix A, and 2 minus 1, 3, 2 minus 1, 3. This is matrix A. Okay, next one minus 8 times identity matrix of order 3 by 3. So 1, 0, 0, 0 1 0 and 0 0 1. Okay, this is identity matrix of order 3 by 3. Next, whole into this whole matrix into what do we take? X bar. X bar is again same story, x1 x2 x3, because 3 by 3 matrix we are taking, so 3 by 1 matrix we have to take here. And null matrix also same, because matrix of order 3 by 3, therefore it is 3 by 1. Okay, then simplify this matrix, two matrices, then what will get? So 6 minus 8 minus 2 and minus 2 and 2. Okay, the next one, second row, minus 2, 3 minus 8 minus 5 and minus 1. Third row, 2 minus 1 and 3 minus 8 again minus 5. So this is a minus 8 times identity matrix, third order identity matrix. Okay, into x1 x2 x3. Okay, and this is equivalent to null matrix of order 3 by 1. Again same story, this is a system of linear equations. So it's like this is matrix V, this is matrix X, this is matrix C. Okay, this is coefficient matrix, and this is variable matrix, and this is constant matrix. So this is a matrix representation of given system of linear equations. Now let us solve the system of linear equations. Solve the system to find the unknown eigenvector. Solve the system. So solving of the system gives you the unknowns x1, x2, x3. Indirectly, x1, x2, x3 is nothing but eigenvector. Okay. Now let us construct the augmented matrix. So here what is augmented matrix? B, C, which is, let us write B, matrix B, minus 2, 2, and minus 2, minus 5, minus 1, and 2, minus 1, minus 5. Okay, and one more, last column, 0, 0, and 0. This is adjoint matrix, augmented matrix. Then we have to convert this matrix into reduced echelon form. Then after that we have to rewrite the system of linear equations. Now let us convert into reduced echelon form. So before that, so first row I want to modify. So R1 divided by minus 2 I want to do, because first non-zero entry should be 1 here, first non-zero entry, right? And similarly, anything else? No. Yeah, I want to do this first. 1, 1, minus 1, 0, and minus 2, minus 5, minus 1, 0. Okay, and 2, minus 1, minus 5, and 0. Okay, now look at here, the first non-zero entry became 1 here, and remaining two column entries must be zeros, so I have to make these two are zeros. Okay, let us make those two zeros. Yes, here R2 I want to modify. R2 is modifying as R2 plus 2 times R1. R2 plus 2 times R1. And R3, R3. So 2 times R1 minus R3. So these two row operations I want to apply at a time. Now first one is not modifying first two, so 1, 1, minus 1, 0. And the second row is supposed to modify R2 plus 2 times R1, 0, 2 plus 2 times R1 minus 3. Okay, next R2 plus 2 times R1, so again minus 3 and 0. Next 2 times R1 minus R3, so 0, 2, so 3, 2 times R1 minus R3, so plus 3, isn't it? 0. Okay, 2 times R1 minus R3, 2 times R1 minus R3. Fine. So next step, so look at here again, this is a leading coefficient and 2 entries become 0. Next one I want this one should be 1, right? Now let's divide the second row with minus 3. So now R2 is modifying as R2 divided by minus 3. Okay, and same simultaneously I want to do R3 also. R3 divided by 3. Both I want to apply. So now let us rewrite. So 1, 1 minus 1 is 0, and 0, 1, 1, 0, and 0, 1, 1, 0. Okay. Now next one, I want this one should be 1, right? I want this one should be 1, and remaining 2 column entries must be zeros, right? I want these two must be zeros. So for that, the row operations are, I want first R3. So R3 is modifying now. How is modifying? R3 minus R2. After that, R1 is modifying now. R1. R1 is modifying as R1 minus R3. R1 minus R2, not R3, because R3 is already modifying. So it's not ready here R3. Okay? Because R3 is already modifying. Understand? If you are getting confusion, you apply one by one row operation. First apply this row operation. Next step you apply this row operations. If you are getting confusion. The only thing is modified row we should not use in the next step. That means here R3 is modifying. Here I cannot write R1 minus R3. Okay. We have to use another row R1 minus R2. Fine. So R1 is modifying now R minus R2. So 1, 0, R1 minus R2. So minus 2, 0. And next R1, okay, R2 is not modifying 0, 1, 1, 0. And R3 is R3 minus R2, 0, 0, 0, 0. Yeah, does it reduce echelon? Look at, so look at this one. So your first non-zero entry 1 remaining 2 column entry zeros, and your first non-zero entry 1 remaining 2 column entries are zeros, and the row consisting of zeros, entirely zeros placed at the bottom. So this is perfectly reduced echelon 1. Now we have to rewrite the system of linear equations. Okay, rewrite the system of linear equation. SLE I am writing. Okay, let's write first one x1. So 1 into x1 minus 2 into x3 is equal to 0. Next 1 into x2. Okay, next plus 1 into x3 equal to 0. And assume this is number, already 1 is used, just call this is number 2, this is number 3. So that can call it. Clear? And so let's simplify this more and more. Modify here itself. First equation is equals to, this first equation implies x1 minus 2 times x3 is equal to 0, and assume this is number 2. Okay, and secondly from second equation x2 minus plus x3 equal to 0, and assume this is number 3. So in these two equations, so now we are about to find the solutions. Now we are at the end. Now in these two equations, which variable is common you have to look at from equation number 2 and equation number 3. Total 3 variables are present, x1, x2 and x3. Which variable is common in both the equation? Both the equation x3 is common. So that's why we have to take that common variable. Okay, let x3 is equal to some k. x3 is equal to some k. K belongs to real number system minus 0. Non-zero number I have to take. Why this is non-zero I will tell you. Okay. If x3 is equal to k, then look at equation number 2. From equation number 2 implies, what is x1 value? x1 is equals to 2 times x3, right? From equation number 2, which implies 2 times, what is x3 value? K. So 2k. This is x1 value. Okay. Next value from equation number 3. So from equation number 3, here only, equation number 3 implies this. What is x2? X2 is equal to minus x3 is nothing but how much? Minus k. Minus k. So therefore the final solution is equal to, in this case, next calculations here I am writing. Okay. So x1, x2, x3, all the values we got. Therefore finally I can write as therefore solution. Now what is solution now? Solution is equal to, now what is solution? X1, x2, x3. This is solution, right? What are these three unknowns? It is nothing but what is x1 now? X1 is 2k. Okay, and 2k. And what is x2? X2 is minus k. Minus k. And what is x3? X3 is k. X3 is k. That's it. So here if you want to take common, you can take out, k is out. So once k is out, now what do we get? 2 minus 1 and 1. 2 minus 1. So this is the eigenvector with respect to the eigenvalue lambda is equal to 8. Now this is the eigenvector. Okay. Now here why I have taken k r minus 0. For example, k is equal to 0, substitute here. 0 into this entire vector becomes 0. So eigenvector is equal to 0 bar you are getting. But eigenvectors are non-zero. That's why k should not be 0. You have to take non-zero number. So how to verify whether this is right or wrong? You got answer k into 2 minus 1 1, right? Simply you have to verify, cross verify like this. First you take any of the k value. For example, k is equal to 1. Substitute here k is equal to 1. What do we get? 2 minus 1 1. Okay. So 2 minus 1 1 is eigenvector corresponding to the eigenvalue lambda is equal to 8. Then how to verify? See, already A matrix is there with you. This one is a matrix A. Okay, simply you write Ax is equal to lambda x. Here also you can verify Ax is equal to lambda x. Here matrix A already given, you write the matrix A, and x is equal to, you substitute this value. What? 2 minus 1 1. 2 minus 1 1 you write here. Okay, is equal to lambda value how much? 8 into, it is 2 minus 1 1. Now multiply, it has to be satisfied. Then only 1 minus 1 is the eigenvector, because Ax is equal to lambda x, those x's are said to be eigenvectors. Understood? Compulsory will satisfy. For example, if k is equal to 2 you take here, k is equal to 2, then what it becomes? 4 minus 2 2. 4 minus 2 2. Again same story. A already given in the question, write A matrix here, and x is 4 minus 2 2. Substitute here. Multiply this. Keep aside. Next, it should be equivalent to 8 times 4 minus 2 2. Multiply this. Both should be equivalent. Then only 2 minus 1 4 minus 2 2 is a eigenvector. This is a cross verification whether your answer is right or wrong. Okay. So this is about eigenvector with respect to the eigenvalue lambda is equal to 8. Next one. Second problem. Look at this problem. Find eigenvalues and eigenvectors of this matrix. So here I have taken a different matrix. Okay. What kind of matrix I have taken here? Look at. I have taken an upper triangular matrix. Look at. This is an upper triangular matrix. Now I am going to establish a note about eigenvalues for these type of matrices, upper triangular matrix and lower triangular matrix. Now let us enter into calculations. Solution. First, what I want? Eigenvalues. How to get eigenvalues? From the characteristic equation. So assume this matrix is some A is equal to this matrix. So the characteristic equation of the matrix A is given as determinant of A minus lambda I equal to 0. This is a characteristic equation. So first you write the heading eigenvalues, right? I'm going to calculate eigenvalues. Eigenvalues can be obtained from the characteristic equations. So first eigenvalues. Okay. So now let us establish this equation. So from that I will get what are the eigenvalues. Yeah. So first matrix A. Let us write the matrix A. 1, 1, 0. Next 0, 2, 2. Next 0, 0, 3. This is given matrix A. Okay, matrix A minus lambda times identity matrix. So which order identity matrix have to take? 3 by 3. Why? Because the given matrix order is 3 by 3. A is of order 3 by 3. So therefore, here the matrix identity matrix we have to take as 3 by 3 order. Okay. 0, 0, 1. Okay. Determinant of this is equal to should be 0 such that lambdas are eigenvalues. So now let us simplify this. This is equivalent to, simplify 1 minus lambda first entry and second entry 1 only, third entry 0 in first row, and next 0, 2 minus lambda and 2. Third entry, third row 0, 0, 3 minus lambda. Okay, and get of this matrix. So 1 minus lambda into S. So this is, I'm expanding through this entry, so this one into this and this one into this, right? So 2 minus lambda into 3 minus lambda and into 2 minus 0 is 0, minus 0. Next one minus 1, so minus 1 into next one with respect to 1 we are expanding, therefore these 0 into 3 and 0 into 3 minus lambda and minus 0 into 2, this one you have to do, isn't it? So what will you get? 0 minus 0 only, because we are multiplying with these two zeros, right? Next plus 0 into, so anything will be 0, which is finite. So now here what we will get? We are expanding through last entry, so we will get, so this one into this minus this one into this, 0 into that, right? So what will we get here? 0 minus 0 is equal to 0. Look at what you are observing is, because of these two entries zeros, okay, because of these two entries are zeros, what we are getting? This last two becoming 0. This is possible in lower triangular matrix only, right? So these two, understood? Now what we are getting here? So now the resultant determinant is, so therefore let us simplify this. 1 minus lambda into 2 minus lambda into 3 minus lambda is equal to 0. Now let us take 1 minus common from all the three terms. So you get minus of lambda minus 1, lambda minus 2 and lambda minus 3 is equal to 0. So multiply both sides minus, so you get lambda minus 1 and here is lambda minus 2. This much not required, just directly from here you can write all the eigenvalues are 1, 2, 3. Okay, and now therefore eigenvalues are, eigenvalues are, for eigenvalues lambda 1 is equal to 1, next lambda 2 is equals to 2, next lambda 3 is equal to 3. So these are the eigenvalues. Indirectly 1, 2, 3 are nothing but, look at here, 1, 2, 3 are nothing but diagonal entries. Look at here, what are the diagonal entries? 1, 2, 3 only, right? So if a matrix is upper triangular matrix or lower triangular matrix, then eigenvalues are without computations. The diagonal entries are the eigenvalues. That's it. So directly I can say that eigenvalues are 1, 2, 3 without computations. Why? Because since it is a diagonal, it is an upper triangular matrix. Okay. So since because of these two, what happening here? Because of these two entries, last two expansions becoming 0. That's what only product of 1 minus lambda, 2 minus lambda, 3 minus lambda. Indirectly, product of diagonal entries only. 1 minus lambda, 2 minus lambda, 3 minus lambda I am getting. You get 1 minus lambda, 2 minus lambda, 3 minus lambda. Indirectly, what are that? Those are nothing but diagonal entries. So which are eigen values. It is not only upper triangular, you can take lower triangular also. For lower triangular matrix, here you will get two zeros, right? So because of that two zeros, again you will get the product of diagonal entries. Again same diagonal entries are the eigen values. So here the observation from this. Note, characteristic roots are eigenvalues of a triangular matrix. Triangular matrix means either upper triangular matrix or lower triangular matrix are diagonal elements of the given matrix. So these are the eigenvalues of the triangular matrices. So without computations, directly you can write, no problem. So if it is a triangular matrix. Next, come to the eigenvalues. How to write eigenvalues? Eigenvalues. Sorry, eigenvectors, right? Eigenvalues are all eigenvectors. Eigenvectors. Next, eigenvectors. First, in this case 1, there are 3 eigenvalues. Case 1, now with respect to first eigenvalue 1, we are finding what is eigenvector. Okay, now let us proceed. What is that? A minus lambda I into x bar is equal to null matrix. Here A minus, what is lambda? Lambda is 1 into identity matrix of order 3 by 3 because given matrix A is of order 3 by 3 into x bar is equal to 0. Okay, now let us substitute back what is A. What is A? 1 1 0 1 1 0 1 1 0, next 0 2 2, next 0 0 3. This is matrix A, upper triangle matrix. Okay, matrix A minus 1 into identity matrix of order 3 by 3 1 0 0 and 0 1 0 and 0 0 1. This is identity matrix of order 3 by 3. Okay, so all these things into again unknown x1 x2 x3. Why? Because the given matrix of order 3 by 3. So here 3 unknowns is equal to null matrix 0 0 0. Okay, and now simplify. First one, so 1 minus 1 0 1 0, next 0 1 2, next 0 0 2. Okay, this is the resultant matrix of A minus I3 and into unknown x1 x2 x3 x1 x2 x3. Okay, into null matrix. Null matrix 0 0 0. Again same, these are system of linear equations, right? So we have to solve it like it is a matrix B quotient matrix, this is variable matrix and this is constant matrix. B into x is equal to C. So we have to solve it, right? Solve the system to find the unknown. Solve the system by Gauss-Jordan elimination method. We are solving it. So now for that, what do we have to do? We have to construct the augmented matrix. What is augmented matrix? B, C, C. This is equals to, what is B? 0, 1, 0, 0, 1, 2, 0, 0, 2. Okay. So, and last one, last column is, the last column 0, 0, 0. So this is adjoint matrix or augmented matrix. And you have to convert this matrix into reduced echelon form, right? And in this, look at the first non-zero entry is 1, right? See, don't confuse with first non-zero entry and first entry. Here first entry means this is the first entry, right? But I don't want first entry should be 1. First non-zero entry should be 1. Here first non-zero. So in the second row, okay, first row, first non-zero entry is 1, remaining 2 entries must be 0. I have to make these two as zeros. For that, what I am doing is, now let us apply the proper row operations for this. So now second row is modifying, like R2 is modifying as R2 minus R1. Okay, now this become 0 1 0 0 and 0 0 2 0 and 0 0 2 0. Okay, and next one, yeah, click at the next one, and here I got the requirement first non-zero is 1, remaining 2 entries must be 0. Similarly for second row, the second row this one should be 1 and remaining 2 entries must be 0. So for that what I am doing is, let us divide the second row with, so I am modifying second row with 2, I am dividing with 2. So now this become 0 1 0 0, okay, and 0 0 1 0 and 0 0. Let me write the third one also. R3 is R3 divided by 2, okay, 0 0 1 0. Next one, is it reduced echelon form? It is not in reduced echelon form because only this one satisfied, but here the first non-zero entry and second row is 1, but I want this one should be 0. So for that, R3 is modifying as, how it is modifying? R3 minus R2. Now this becomes 0 1 0 0 and 0 0 1 0 and 0 0 0 0 4. Now this is perfectly reduced echelon form matrix. Now next what to do? Rewrite the system of linear equation because it is reduced echelon form. So rewrite system of linear equations. What do we get? So 1 into 0, 1 into x, 0 into x1 and 1 into x2, right? 1 into x2 is equal to 0. Next 1 into x3, right, is equal to 0. So this implies I got x2 is equal to 0 and from here got x3 is equal to 0. Okay, so now x2 is equal to 0 and x3 is equal to 0 I got. Okay. Then what about x1? If x1 is not obtaining, then call it as, so therefore let that x1 is some k. Again k belongs to real number system, non-zero real number. Non-zero real number means normal is 0. Except 0 we have to choose any of the k. Now therefore solution is, so therefore solution. Now what is solution? Solution is equal to x bar, which is nothing but eigen vector. Okay, eigen vector. Okay, and which is nothing but what is that? First x1, next x2, x3. Okay, this is nothing but, what is x1? Here x1 is k, so let us write k. x2 0, x3 0. Okay, and this implies, let us take k common, 1 0 0. That's it. So this is the eigenvector corresponding to the eigenvalue lambda 1 is equal to 1. So here k belongs to r minus 0. Okay. So for k is equal to 1, because k belongs to the number system, for k is equal to 1, what will get 1 0 0, right? Take this 1 0 0 and verify like this. So already we are having the equation ax is equal to lambda x. Okay, lambda x. In this already a is given to us, which is upper triangular matrix, and what x we are taking here? X we are taking as 1 0 0 we are taking. K is equal to 1. Take this one as x. And what is lambda here? This is eigenvalue with respect to the lambda is 1, right? And 1 into 1 0 0. Now verify this. It has to satisfy compulsory. It will satisfy definitely. If it is not satisfying, it is not an eigenvector, right? So it will satisfy. Similarly, if k is equal to 2, let us write 2 0 0. Again, instead of 1 0 0, let us write here 2 0 0. Again, same matrix, again matrix is equal to same lambda, okay, into same 2 0 0 into 2 0 0 into. It has to satisfy definitely. Then only it is Eigen vector and it will satisfy. So like this you can verify, cross verify like this. This is a cross verification. So finally this is the Eigen vector corresponding to the eigenvalue lambda 1 is equal to 1. Similarly, second eigenvalue, so case 2, right? Case 2. Case 2 for lambda 2 is equal to 2 with respect to second eigenvalue 2, right? So then a minus lambda I3 with a raise of order 3 by 3 into x bar is equal to null matrix. And what is A? The matrix A is 1 1 0 0 2 2 and 0 0 3. This is the upper triangle matrix. This is matrix A minus what is lambda here? 2. 2 into identity matrix. What is identity matrix here? 3 by 3 identity matrix because A is of order 3 by 3. 1 0 0 0 1 0 and 0 0 1. Okay, and all these things into the unknown x1, x2, x3, or you can take x, y, z for simplicity, no problem. Some unknowns we have to take x, y, z or alpha, beta, gamma or x1, x2, x3, whatever. Okay, is equals to what do you take? Null matrix, right? What is null matrix? 0, 0, 0. Like this. Then simplify this. Okay. This is equivalent to, let us simplify, 1 minus 2. So minus 1 first entry, second entry 1, third entry 0 in first row. And second row 0, 0, 2. Okay. And 0, 0, 3 minus 2, 1. So this is a resultant matrix of A minus 2 into I3 and into the unknown x1, x2, x3, x1, x2, x3 is equal to the null matrix 0, 0, 0. Again same story, we are getting system of linear equations. So it is like some matrix B, coefficient matrix, it is like variable matrix, it is like some constant matrix. So system of linear equations we are getting. So therefore solve the system. Next step, solve the system. Again same story, everything is same. Solve the system. Then before that what we have to do, we have to construct the system of, we have to construct the augmented matrix. We see. This is augmented matrix. Right. Now what is the minus 1, 1, 0, 0, 0, 2, 0, 0, 2, 0, 0, 1, 0, 0, 1 and last column 0, 0, 0. So this is augmented matrix. So I want this one should be 1, therefore first non-zero entry should be 1, so that we have to make it 1. So for that what I am doing is first row 1 I am modifying as minus 1 into R1. Okay, and similarly row 2 I am modifying as R2 by 2 because second row first non-zero entry should be 1. That's why I am dividing with 2. Okay, now this is 1 minus 1 0 0. Clear? And second row 0 0 1 0. So dividing with 2 and 0 0 1 0. Okay, now here look at, is it reduced echelon? Check once. First non-zero entry is 1, remaining 2 column entries zeros, and second row first non-zero entry is 1 and remaining 2 column entries must be 0. But here I have to make this one as zeros. Then make that one as 0. Yes. Yes. So now R3 is modifying now. R3 is modifying as R3 minus R2. Now this matrix becomes 1 minus 1 0 0. Next 0 0 1 0. Next 0 0 0 0. Now is it reduced echelon? Check once. So it's perfectly reduced echelon matrix. Then rewrite the system of linear equations. rewrite the system of linear equations once it is reduced echelon form. Then rewrite. So 1 into x1, so x1 minus x2 equal to 0, isn't it? Next, x3 equal to 0. So assume this is a number, call this is number 1, this is equation number 1, then this is equation number 2. Okay, now look at equation number 1 implies x1 is equal to x2, right? x1 is equal to x2. So both should be same, therefore x3 is 0, directly I got x3 value 0. But what is x1, x2? x2 and x2 are same numbers. If you take x1 is equal to some number 2, then x2 also 2 only. If it is 3, it should be 3 like that. Therefore, let x1 is equals to x2 is equal to some k you choose. K belongs to real number system minus 0, non-zero number you are choosing. Then now solution is, so therefore final solution is nothing but x bar is nothing but eigen vector, isn't it? Eigen vector, which is nothing but what? x1, x2, x3. Okay. And here what is x1, x2, x3? What is x1 now? x1, x2 both are k, right? So x1 is k, x2 is k, and x3 is 0. So you take k out, 1, 1, 0. So this is eigen vector corresponding to the eigen value lambda is equal to 2. Again, if you are getting doubt, again same story, is a cross verification, how to verify your answer right or wrong. Simply take Ax is equal to lambda x, okay, and matrix are already given to you, the given matrix, that means upper triangle matrix, and instead of x you take this eigenvalue. For example, k is equal to 1 because k belongs to r minus 0, right? So any number you can take 2, 3, 4, 1 by 2, root 2, whatever the number you take you wish. So if k is equal to 1, 1 into this 1, 1, 0, I will get 1, 1, 0 only. Then for that 1, 1, 0, okay. And what is lambda? This is eigenvector for which lambda? Lambda is equal to 2, right? So 2 and again 1, 1, 0. Definitely it will satisfy. It is true because it is an eigenvector. And if you take k is equal to some 3, for example, then 3, 3, 0. Then here you have to take 3, 3, 0, and lambda is 2 only, and this is 3, 3, 0. Again verify this, it becomes true. Then only it is an eigenvector. Otherwise, it is not an eigenvector. It will satisfy that. So this is about eigenvectors with respect to the corresponding eigenvalues of upper triangular matrix.